Hello everyone, welcome to the chemistry guide. Today's topic is VSEPR theory. VSEPR theory stands for valency shell electron pair repulsion. This theory explains the shape of molecules. According to VSEPR theory, electron pairs means bond pairs and lone pairs present around a central atom repel each other. Because of this repulsion, they arrange themselves as far apart as possible. This arrangement decides the 3D shape of the molecule like linear, trigonal planar, tetrahedral, etc. Electron pair repulsion. All valency shell bond pairs and lone pairs repel each other because they have negative charge. To reduce repulsion and become more stable, molecules arrange electron pairs far away from each other in 3D shape. Let's see the order of repulsion. Lone pair greater than, lone pair greater than, bond pair. Here, lone pairs cause more repulsion than bond pairs. Let's see the geometry of molecules in which the central atom has no lone pair of electrons. For example, here BeCl2, HgCl2. Here beryllium and mercury are central atoms with 2 valency electrons each. It forms 2 single bonds with 2 chlorine atoms. To maximize the distance between 2 chlorine atoms, they arrange themselves in straight line. Therefore, the molecule shows linear geometry with bond angle of 180 degrees. Next example, BF3. Here, boron is the central atom and it is bonded to 3 fluorine atoms. Boron has 3 valency electrons. It uses the electrons to form 3 single bonds with 3 fluorine atoms. There are no lone pair on boron. Because of there are 3 bond pairs and no lone pairs, the atom arrange themselves as far apart as possible to reduce repulsion. So the shape of BF3 is trigonal planar. In methane, carbon is the central atom. It is bonded to 4 hydrogen atoms. These 4 CH bonds repel each other to stay as far as apart as possible and they form tetrahedral shape with the bond angle of 109.5 degrees. Next example, PCl5. Here phosphorus is the central atom and it attached with 5 chlorine atoms. Here phosphorus has 5 valency electrons. It uses all 5 electrons to form 5 single bonds with 5 chlorine atoms. So there are 5 bond pairs and no lone pairs. According to VSEPR theory, these 5 bond pairs arrange themselves to stay as far apart as possible and form trigonal bipyramidal shape with bond angle of 120 degrees. Next example, SF6. In sulfur hexafluoride, here sulfur is central atom and 6 fluorine atoms around it. Sulfur forms 6 bonds with 6 fluorine atoms. There are no lone pair on the central atom. To reduce repulsion between these 6 pairs, they arrange themselves as far apart as possible and form octahedral shape with the bond angle of 90 degrees between adjacent sulfur fluorine bonds and 180 degrees between opposite sulfur fluorine bonds. Next, we will see geometry of some molecules or ions with central ions having one or more lone pairs of electrons. For example, SO2. Here sulfur is the central atom. It has 2 bond pairs and 1 lone pair. And geometry of the molecule trigonal planar. And shape of the molecule bent. Next example, NH3. Here central atom is nitrogen. Nitrogen bonded with 3 hydrogen. So bonding pairs 3 and lone pairs 1. Here geometry of the molecule tetrahedral and shape of the molecule trigonal pyramidal. Next example, H2O. Here oxygen is the central atom. Oxygen attached with 2 hydrogen atoms. So bonding pairs 2 and lone pairs also 2. And geometry of the molecule tetrahedral and shape of the molecule bent. Next example, SF4. Here sulfur is the central atom and bonding pairs 4 means for attached with 4 fluorine atoms and lone pair is 1. And geometry of the molecule trigonal bipyramidal and shape of the molecule seesaw. Next example, ClF3. Here central atom is chlorine and chlorine attached with 3 fluorine atoms. So bonding pairs 3 and lone pair is 1. And geometry of the molecule trigonal bipyramidal and shape of the molecule T-shape. Next example, BrF5. Here central atom is bromine. Bromine attached with 5 fluorine atoms. So bonding pairs 5 and lone pair 1. Geometry of the molecule octahedral and shape of the molecule square pyramidal. Next example, XeF4. Here central atom xenon and xenon attached with 4 fluorine atoms. Here 2 lone pairs are present and geometry of the molecule octahedral and shape of the molecule square planar.